Some other people might say that this is the most complicated example, or most complicated kind of problem you could see on the AP test. And that would be because this involves trigonometry, and some of you are still a little nervous about trigonometry despite purple card therapy. So here's what we know. We have a balloon, a hot air balloon that's lifting straight off the ground. 500 feet away from where it lifted off, there's someone or something on the ground that's watching the balloon. And so that angle of elevation, that angle of eyesight is changing. The higher the balloon gets, the bigger that angle has to get. So we've been told that at the exact moment that theta, the measure of the angle, is pi over 4, that the rate at which the angle is changing is 0.14 radians per minute. So we know d theta dt, the rate at which the angle is changing. What have we been asked to find? We've been asked to find how fast the balloon is rising. So if you can make a picture like this that includes the balloon moving up and 500 feet away, there's someone or something on the ground who's got an angle that's changing, you can come up with this picture. And if we look at this picture, the rate at which the balloon is changing, well, the distance between the balloon and the ground is h. The rate at which that is changing is dh dt. So that's what we're looking for. We're looking for dh dt. And here's the tricky part. Can you write an equation that relates h, and theta? So I hope you're already thinking about a trigonometric equation. So the tangent of an angle is its opposite, the triangle's opposite side over the adjacent side. So that's what we're going to use. So this is the equation I'm going to write. It says that the tangent of an angle is the opposite side divided by the adjacent side. So tangent of theta is h over 500. Then my next job is to take the derivative of both sides with respect to time. Well, the derivative of tangent with respect to, the derivative of tangent theta with respect to theta is secant squared of theta. We need to multiply by d theta dt. Here, over here, this is 1/500th h. So the derivative of 1/500th h is 1 over 500 times dh dt. Once you have that, once you have this equation that comes from taking the derivative of both sides with respect to time, all that's left to do is to plug in the information from the original problem. We know that we care about the rate of change of the height at the exact moment that theta is pi over 4. So instead of secant squared of theta, now I know I can take secant squared of pi over 4. I'm going to multiply by d theta dt, which I know is 0.14, is going to have to equal 1/500th dh dt. I'll move to the next slide. All right, this next part is going to be up to you to do on the AP test, but I have a picture up here to help you if you need a reminder about how to find the secant of pi over 4. Where's my... There we go. So in a right triangle, if I have an angle of pi over 4, then my coordinates up here, the x and the y, are 1 over square root of 2 and 1 over square root of 2. You might remember them as radical 2 over 2. It's fine. So secant is 1 over the cosine. Cosine is opposite over hypotenuse. So the secant of pi over 4 is hypotenuse over the opposite, radical 2 over 1, which just makes radical 2. So secant of pi over 4 is radical 2, which is going to get squared, times d theta dt is 0.14. That's going to equal 1/500th dh dt. You can see we come over here. I'm going to multiply both sides by 500 to get that dh dt by itself. And here we go. I got 140 feet per minute for the rate of change of the height of the balloon.